So for this one, okay, this problem says, yeah, basically you're shooting an electron into a field. So there's like this, there's a hole, the electron's going to shoot up like that. The bottom's positive, the top's negative, 2 centimeters. Okay, yeah, so this is plus, this is minus. Oops. So basically this is an electron, so it's just going to go whoop, boom, like that. So this is just projectile motion, that's all it is, right? And then what they did first, what we need to do first, is come up with the acceleration, like come up with gravity, basically, okay? And then once we've got gravity, then they're just using two-dimensional motion. Right? That's the whole idea. Right? So here, this is this is x0 v 0 t plus 1/2 at squared. Why are they doing t1 minus t0? That's weird. Yeah. Oh, sorry. No, I get what it means. I don't know why they're doing that. Okay, so they're saying something like you shoot this thing up at an angle, and then you know that it lands 4 centimeters away. And you know that it has a speed of 5 times 10 to the 6 meters per second, and its angle is 45 degrees. Yeah, so then coming up with everything is pretty straightforward, right? What we're going to do, since we know x, it's two-dimensional motion, right? So we know x and we know y, and we can use both of these things to come up with the acceleration. Once we know the acceleration, then we can calculate the strength of the electric field. I think that's what they wanted. Yeah, the electric field strength. Okay, so first I'll use x and say x is going to be vx times t. So t is x over vx. That means x over v cosine theta. So then, what is that? So, I don't know, it's going to be some really tiny number, right? So 0.04 meters divided by, what, that's going to be around 3.5 times 10, because it would be 0.7071, so 3.5 times 10 to the 6th meters per second, and you get some massively, so, yeah, whatever. This is going to be like, I don't know, around 1 times 10 to the minus 8 or something like that. What do you get? 1 point times 10 to the minus 8 seconds. Okay, everybody cool with that? So then, now we know this. Y equals Vyt plus 1/2 at squared, right? I mean, kind of like, I don't know, well, whatever. We can just do this. And then we know that y is 0, because it lands where it stops. Also, we can also say this is negative, right? Because the velocity is up, the acceleration is down. So I get, and then Vy, of course, is going to be V sine theta, which is going to be the same thing, but whatever. T is equal to a over 2 t squared. That t cancels with that t, and we get a is equal to 2 V sine theta over t. So now, V sine theta, we saw that's already 3.5 times 10 to the 6th. So divide that by 1.1 times 10 to the minus 8. That becomes 7. Divided by 1.1, we're going to get 7.5 or 8, close to 8 to the 14 or something. What do you get for the acceleration? That's a guess, but what? Right, because this is 2 times 3.5, so it's going to go to 7 times 10 to the 6th. So 7 times 10 to the 6 divided by 1.1 times 10 to the minus 8. So we know that's going to be the 14. So what's 7 divided by 1.1? Around 6 or something? 6 something? What do you get? 6.2? So you get 6.2 times 10 to the 14 meters per second squared? Yes, no? Okay. I don't want to leave anybody behind. Is this okay? That's just the acceleration. But wait, there's more. Okay, now we know that this electron traveling through space, right, traveling through this field, that the field is doing this because it yanked the electron back down. So what is the sum of the force, or what are the sum of the forces on this thing, right? So we know, we don't have to worry about gravity, so I'm not going to, that's kind of insignificant based on the mass. So the only thing is this pulling down, right? So the sum of the forces on that little thing is going to be EQ, yeah? Okay, and so EQ, I'm sorry, what I should have said, pardon me, I should have said this is going to equal MA, and then I should have said EQ is equal to MA. That way I could get Q, not Q, hello, E is equal to MA over Q. So M is going to be 9.11 times 10 to the minus 31. A was, what, 6.2 times 10 to the 14? 6.2, gotta move this. 6.2 times 10 to the 14. And then the charge is going to be 1.6 times 10 to the minus 19. So then we see, just for funsies, this and this is 17. So this is going to, it's negative, so I'm sorry, it's negative 17. So it's going to be positive 100, basically, right? It's going to be 100. So then what is 9.11 times 6.2 divided by 1.6? So it's going to be, the answer is going to be times 10 to the 2. Anyone? Anyone? Good gracious, the people have calculators. Do this quickly. Bark it out. Well, yeah, what do you get? 9 times 6 is 54. Add some change, like 56 maybe, divided by 1.6. What? 35.3. There you go, 35.3 times that, so 3,500 maybe newtons per coulomb. Okay, so if we go to this and check our answer, see if that's completely wrong or not. And oh, okay, there it is. I was like, oh crap. Yeah, so we're doing good, right? Everybody cool with that? Okay, so then the second part is, what is the minimum spacing between the plates? So the second part is the second part is how high is that, right? So the easy way to do that, I'm thinking, is to use the fact that Vy up here is 0, right? When it stops on the way back down. So I'm going to say V final is equal, V final squared is equal to V0 squared plus 2ax. And in that case, we're talking about y, so I'll just call that x because I'm being bad. Okay, I shouldn't do that. I don't want to confuse people. Let me call that y, 2ay. So then y, this y is going to equal v squared minus v0 squared all over 2a. Our v squared, we know that's 0. So take this right there, take this right there, and then we'll get our answer. So, I don't know what 3.5 squared is, like 12 or something, 11. And then so that becomes 12, and then 14, I don't know, plug it in. So 3.5 times 10 to the 6th squared divided by that. What do you get? 1? Oh, that's terrible. I should have been able to identify that in mental math. Come on, Kevin. 2 would give us 12.4 times 10 to the 15. No, 1.24 times 10 to the 15. This squared is going to be, yeah, that makes sense. Yeah, did everybody see that mental mathy wise? This is going to be like 11. I said 11 or 12 times 10 to the 12. And this one multiplied by 2 becomes, let's say, 12 times 10 to the 14. So when you flip it, you get to the minus 2, so you get 0.01 or 1 centimeter. So we're good. Yay. Yeah.